how's everybody doing? How can I be of assistance to the masses?
Let's see what I've got now, because technically I'm starting at square one from biochem, so I don't know what I've accessed and what I've not. In here. To say with week 3, just like making sure we know the proteins and how they function.
Ooh, proteins. I love proteins. Yeah, one day you might look back on this and think it's all cool. Today might not be that day, but maybe one day. Books. Try one books. Biochem. Dr. Sarkar's book.
I had a question. It was from the quiz. Am I allowed to discuss those questions?
Is the quiz closed?
No.
If you have a specific question about a quiz that is not closed, you can send me a message directly.
Okay.
Just as long as the quiz is still open and possibly other people haven't taken it, not allowed to discuss that kind of stuff until it is closed and everybody can see it.
Okay.
So if you have a specific question about that, just send me a private message, either on GroupMe, email, or whatever.
Okay, thank you.
Let's see. Let's quickly go through this book of stuff and see if we can answer questions. So, chapter 1, review of basic chem. How does everybody feel about basic chemistry? Any big questions or concerns about all of this stuff?
Doing okay with it. Still struggle time to time, but
okay.
Question by question, I think.
Things you'll want to for sure remember out of here. Let me pull this up in my, I don't know why it opened up in Google Chrome. Important stuff to remember. The difference between like kind of what, let's see, open with Microsoft Edge. There we go. Some of the stuff you want to focus on, understanding differences between ionic bonds, covalent bonds, and hydrogen bonds. What the difference is between those, what kind of things form those bonds. Page 23. So ionic bonds, they have positive, negative charges, and that's what forms together. Covalent bonds, they share the electrons. The hydrogen bonds forms hydrogen atoms, form polar bonds with the other things in order to stick so much stuff together. Well, when we talk about proteins and building proteins and making proteins, we talk a lot about bonds. We got water. This first exam, you'll have a couple of questions about hypo and hypertonic solutions, as well as like isotonic, osmosis, those kind of keywords. You should see a couple of questions about those. Acid, bases, pH, and buffers. We talked a tiny bit about this. We talked about weak and strong acids and bases. Do we remember that from last week? We talked about that.
Mostly.
Yeah.
If we talk about a weak acid or a weak base, what is that weak referring to? What do they do? What does a weak acid do weakly?
Give hydrogen.
Partially.
Good. So it partially dissolves and gives off some of its hydrogen, but it's a little bit more kind of reserved. It likes to hold on to its hydrogen. What about a strong base? What does a strong base do?
Strongly
Takes
gives
all the
away.
hydrogen.
It takes all the hydrogen.
Or
Yeah,
takes it. Yeah.
it completely or strongly grabs the hydrogen out. And we didn't talk about this last one, but Dr. Sarkar should have mentioned a little bit. What does it do to pH? First of all, let's back up a sec. What is pH telling us? What does pH measure?
The hydrogen concentration of a solution.
Perfect. It measures how much hydrogen is free floating hydrogen is just floating around in a solution. So if we put a strong acid, into a solution, what is it going to do to the pH?
Decrease.
Yeah, drop it.
Good. The pH will decrease because the more hydrogen we have, the more acidic the solution and the more the lower the pH value. And so that is opposite for bases. He'll ask you questions like that. The way that he'll word it is kind of like a long drawn on sentence, including stuff like you might see a couple words, like you might see like hydrochloric acid or a phosphoric acid, one of those two. Those are two really common ones. With these ones, anytime you see hydroxide, you know that that's a base. So he'll give you something like that and say, you put this into the solution, what occurs to the pH? He'll say it in more fluffy words, but that's essentially the kind of the point that he's going to make.
Yep, I can confirm that.
Yeah. Acid base, here's our whole pH meter. Buffers. We didn't talk a lot about buffers. How do we feel about buffers?
Not great.
Okay. Does anybody feel okay-ish with buffers?
Okay-ish is the operative word.
Okay.
Yeah.
Okay. So when we talk about a buffer system, what we're talking about is a weak acid and what's called its conjugate base. So when you put a weak acid, such as H2CO3, that is a weak acid. It releases hydrogen and forms a conjugate base. So you have a weak acid, you put the weak acid into the solution, part of its hydrogen comes off, and then its HCO3 is floating around, and that's its conjugate base. So all of these together, a weak acid floating around in a solution, giving off its hydrogen, forming a conjugate base, that's what makes a buffer system. Let me pull up. This is important. This is where I'll try and give you guys some of like the future knowledge of like why the heck does this matter. I
feel like that's what helps me with remembering is like why it matters. So
yeah, and actually this equation right here that he gives you is actually one of our blood buffer system. It's a little bit more drawn out here, but it's called our bicarbonate buffer system. So this is how our body gets rid of CO2, is through this buffer system. So it's a way to maintain and balance pH inside of a solution. So within our bodies, I think he has it here somewhere where I wrote it down. Normal pH range, this part right here, normal pH range of blood is 7.35 to 7.45. That's extremely specific. If it goes outside of this, even by like 0.01, bad stuff starts to happen. Like literally the proteins in our bodies stop working and they start to unravel and we die.
Yep, it's really kind of scary to see when you're in the ER working as a tech.
Yeah. So this system, this buffer system, transporting this back and forth to maintain pH balance is why this system is super, super important. So how does like the whole thing work? You'll see a couple of equations. You'll see these equations. What I'm going to recommend that you do this for all of your courses. Whenever you get an equation, write out each individual part of the equation and what it represents. So every single time you see brackets like that, brackets, when you see brackets, that equals a concentration. That's what that's telling you. So a concentration of whatever is inside of this brackets, that's what that means. So bracket H plus equals the concentration of hydrogen. Bracket A minus is the concentration of the acid. Nope, I lied. Let me double check. It's been a little while since I've looked at this equation. The KAH acid dissociated K. Yeah, okay. A minus is the concentration of the conjugate base. And then our HA is the concentration of acid. Because remember, a buffer is a weak acid. And so if it's a weak acid, you're still going to have concentration, a little bit of concentration of acid, which is why the buffer system is a weak acid. So I recommend anytime you run across an equation, because he's going to ask you questions, not to calculate stuff, but he's going to ask you questions about parts of this equation. So he's going to say something like, you put in so many more milliliters of acid into the solution. What occurs to the Ka? So if you add a bunch more of the acid, its bottom number gets bigger. What happens to our Ka value?
Decrease.
It decreases. So that's the kind of question that he'd ask you about this. So understanding what the equation kind of means and how it's going to affect different things is kind of the way that we want to think about equations. And that is, and also we want to say Ka. Ka is it's called the acid dissociation constant. Like that. So every single equation that you run across, this is super, super helpful to understand each of its components and kind of play with it like that. You want to be able to understand if one of these goes up or one of them goes down, what happens to the overall value and why. Those are the kind of questions that you'll get. Okay. Any questions about, in general, weak acids, weak bases, buffer systems? This is really like the most advanced stuff that he'll ask you about, kind of equation wise. Like he'll say you have like a weak acid or a conjugate base and you add more of something and like what happens, like what changes. So that's what a lot of the questions that he'll ask about that. Henderson-Hasselbalch equation. It's derived from this whole thing. You do a whole bunch of fun math stuff. If you want to really understand this equation, if that's kind of what floats your boat, Ninja Nerd, Henderson Hasselbalch equation. If you don't know who Ninja Nerd is, I love Ninja Nerd. Right, give me 1 sec. Okay. As well as Khan Academy. I saw you guys floating a couple of Khan Academy videos out there. Khan Academy is really, really great for a lot of these things as well. I love Khan Academy. I love Ninja Nerd. Both of these sources are fantastic for a ton of your core science courses. So like if you need a refresher or anything, like he has a whole Gen Chem playlist here, acids and bases. He does a lot of the calculations and stuff here as well. But you can use, and he has like whole sections on physiology, neurology, anatomy, all sorts of stuff. And I love, love, love Ninja Nerd. Would highly recommend his page as well. From what I remember, most of what the questions, Dr. Sarkar didn't get super deep into like this actual equation itself. I remember he had a question or two that was like, which of the following represents Henderson-Hasselbalch equation? Like you had to know what the equation was. I don't recall there being a ton other than that. Not sure if Christine is that sort of what you recall, or was there more that he put in with that?
I'm pretty sure that's about what it is.
Okay. And then these other little key little tidbits like pH equals pKa at equal concentrations of conjugate base and acid. So he could ask a question about that as well, relating those two. That's often I remember that being a test type question. Okay. Important buffer systems, bicarbonate buffer. This is the big one. This is, we said this one up here. That's that guy, the bicarbonate buffer system. That you don't get deeper into those. You'll get deeper into those in physiology, like Phys 1, Phys 2. You don't have to worry about that too much right now. We talk about carbon. Carbon's super versatile. We already talked about functional groups. If you haven't been reviewing your functional groups, start reviewing them now. You should be able to go on and find Quizlets already made of functional groups, like what their charge is, what their function is, that sort of stuff. Because start reviewing now. Do 10 minutes a day of functional group stuff, because it will sneak up on you on the exam, and cramming it does not work. And you'll need, I want to say, you will need to know functional groups and like understand what they do for Biochem 2. So setting yourself up now in Biochem 1 will save you a lot of headache in Biochem 2. Okay, any questions so far?
Quick unrelated question.
What's up?
Is your link for your notes still in funded chat?
Probably.
Okay, I have to go look for it because I need the micro one.
Okay. Cool. Okay, amino acids, structure and biochemical properties. Amino acids at pH of 7. Remember this number, 7.35 to 7.45. I don't remember if it was biochem or phys. Asks you that specific question at some point.
You talked about it in your YouTube video
Yeah.
for this class, so
Sweet. Just keep it in mind. Proteins, building up of proteins. Proteins are made by amino acids. Amino acids are going to be the building block of our proteins. Remember, we talked about the side chain, the R group. We talked about that last time. Do you remember what an R group represents? What an R group is?
some random side chain.
Yeah, it's a bunch of stuff represented by an R. You'll see in his tests. So with amino acids and all this stuff, you'll see L and you'll see D isomers.
Yes.
So with L and D, understand In humans, we have L isomers inside of our bodies. So a lot of the times in his questions, he'll put answer choices that are like, so the way that you'll see this written is like L valine, but another answer choice is D
Valine.
valine. And then he'll have D methionine, L methionine, or something like that. Immediately, you know, if we're talking about humans, both of those are immediately gone. We want the L form. We are looking for L because that's what's in humans. Okay. So an amino acid, we briefly covered this last time. An amino acid has a central carbon. They call this the alpha carbon, or a lot of people call it the chiral carbon. Chiral, a chiral carbon is this. It's a carbon that is bonded to 4 different groups of stuff. So for example, in this example, a carboxyl group, an amino group, a single hydrogen, and then our R group, right? This will be a test question. Let me pull up. Nope, glycine structure. This question right here, which of the following amino acids does not contain a chiral center? Every single amino acid contains a chiral center, except for glycine, because glycine, its R group, is just a singular hydrogen. And because there's another hydrogen attached to it on the other side, it is not considered chiral because it has 2 of the same thing bound to it. So that most likely, every time that I've seen, he usually asks a question, something like that. Now we stop and we think, how could he word this question? Same thing, he could also have answer choices be D-glycine and L-glycine. And if he had an L and a D glycine, which would be the correct choice?
L.
L, because L's are the only ones found in humans. Just like the functional groups have certain properties, all of our amino acids have different properties. Their properties are due to this. So in all amino acids, these 3 things are all the same. What's different is their R group. The R group is going to determine the properties of the amino acid, whether the amino acid is basic, acidic, sulfuric, whether it's, what are some of the other ones that he asked about? Ring structure, that sort of stuff. We'll get into those. That is all depends on the R group, because all the rest of this is the exact same on every single amino acid. This down here is showing us again what we just talked about, L versus D. They're stereoisomers, so that they're mirror images of each other. He sometimes asks questions about stereoisomers, like what it is. So it's a mirror image, but just remember that only the L ones are used to make proteins. The L ones are the ones that we use in our bodies. Here are our different side chain groupings: polar, nonpolar, aromatic, positively charged, and negatively charged. Remember, all of these properties are due to or are because of what part of the amino acid?
Electron.
So we look up at our amino acid structure. There's 4 things that it could be due to the amino group, the carboxyl group, the hydrogen, or the R group. What determines the properties of the amino acid.
It's our group.
Yeah, the R group.
The R group, exactly, because it's the only thing that's different. The R group is gonna, if we actually look at this right here, positive, negative, these two balance each other out. And these two are just sharing, so these are neutral. So overall, this whole structure up here is neutral. So the R group is going to determine what kind of properties the rest of the amino acid has. So we have polar, nonpolar, aromatic, positively charged, negatively charged. We have all of these down here. Let me pull up real quick. There's a couple more kind of chunks in here that we want to talk about as well, but you go away, school. I'll have this open while I do this. This is kind of tying it back to this. So amino acids can act as weak acids or weak bases. Again, because we look at a carboxyl group, C double bond O and H3N, it can either donate hydrogens from here or it can accept hydrogens as well. That's why it can act as a weak acid or a weak base. Okay, so we have some of our different groups are non-polar. I should have this all already sorted somewhere. I think I just have one single page with all of this stuff on there. Maybe I don't. Thought I had it somewhere. It's fine. Okay. This right here, a lot like the functional groups, unfortunately, is just going to be a lot of raw memorization. Some of the biggest trick that I have for raw memorization, like you just need to know which amino acids are non-polar. You need to know which ones are polar. The best way to do that, I have found, is like making up either mnemonic devices or whatever it's called, where like each letter represents something like
Like an acronym kind of.
yeah, like an acronym kind of something like that. So honestly, the way that I have done this a lot is all like, did anybody ever play Words with Friends?
Yeah.
So this is literally what I used. You can look at these like helpers, like a Scrabble helper, and you can literally come in here and put in GAPVLIM, and then I'll do one extra. 1, 2, 3, 4, 5, 6, 7. Vamping. So we have an extra N in here. 1, 2, 3, 4, 5, 6, 7. So which one are we missing? We're missing we're missing the L. So L vamping. Or you can even do vampling or something like that. And if this is a lot easier to study and to memorize than trying to just raw memorize every single one of these. So you can go through and you can pick whatever works for you. There's vamping, lamping. Let's even try adding another one here, see if we can get a 9-letter word. No, can't get anything like that, but you see the idea where you can start to find some of these things to start making little things just a little bit easier for yourself. And this is how I would study this is how I would study all of the amino acids. I'd remember lamping, and I'd take this and I'd write it. So I'd write it somewhere. This is how I would study every single day. I remember vamp, LNG, like that. And I would try and, from memory, remember each of these and see how I could get away with everything. So like G is glycine, M, methionine, V, valine, A. There's a couple different A ones. I think it's arginine. Let's see if I still have it in my brain. P, proline, L might be lysine, and something. But you get the idea. Like I try and go through it. So that I look through and I see which ones I was wrong on. Arginine was wrong because it's alanine. Proline, valine, leucine, isoleucine. Ooh. Come back and correct it. Did I miss the I? I'll figure it out. You guys get the gist. This is the kind of the way that I would do to study these. So doing this over and over and over again, and the more you can do it from straight raw memory, the way that you build neural connections is forcing something called active recall. So this, studying like this is active recall. It's forcing you to remember, it's forcing you to write, it's forcing you to go through them, and then literally just delete it and do it again, and then do it again, and do it again, and do that. Do each of the different groups you need to have it memorized. Do it once a day do it until you get it correct once a day for like 4 or 5 days. And then you just need to do it one more time right before the exam, and it's lock and key. It should be in your brain because that's what active recall forces you to do. And it forces your brain to build neural connections and put these things into long-term memory.
You can also use smells to kind of help trigger things too.
Yeah, you can. Using like essential oils. This is actually, you can try this if you would like. Pick an essential oil smell for each class. And every single time that you're watching lectures for that class, doing quizzes or doing anything like that, have that essential oil. Either put it like on your arm or on your somewhere that you smell it. And every time you switch classes, wash it off and switch to a different essential oil. And then when you go to take exams and stuff, put out that essential oil, and it actually does trigger neural responses. You can do the same thing with snacks or food or gum flavors. Like if you want help with a specific subject, chew the same gum or eat the same snack every single time that you do that subject. And this might sound like an autistic thing. It's probably an autistic thing. Every single time I would go to take a test, I would have a bag of in undergrad. I'd have a bag of goldfish and a Coke every single exam. Even if like I had exams back to back, I'd have a bag of goldfish and a Coke every single exam. So creating consistency in that way helps your brain understand, like get in the mood for taking tests and doing that sort of stuff. Okay. Moving on. Nonpolar amino acids. Again, these are all because of our R groups. You do not need to know the exact structure of every single R group. Okay. You do not need to spend your time drawing these. He is not going to give you a picture and say, what amino acid is this? He will not do that. You need to know their properties, which ones are polar, non-polar, which of all of them, this is a question for you guys, which of all of them does not have a chiral center? Glycine. Yeah. So the questions that you'll get asked, which are polar, or literally it'll be, which of the following amino acids is not non-polar? That's probably how I'll ask them. So which of the following is not non-polar? He loves these kind of questions of like not, because then you have to know like which ones are, which ones aren't. Same thing here. Some of the other things that he'll ask you about. Here's what we're talking about. All here, right here, branched chain amino acids. He'll ask you about that. Again, the exact same type of question. Which of the following is or is not a branched chain amino acid. Make sure that you read to the very end of each of his questions. Specifically, like look for words like this. Like not a lot of times he'll end a sentence with a negative or something like this, and people will read the first part of the question and go down and answer it. So like they're like, which of the following branched chain amino acid? Bam, this one. And they won't read the whole question, and it's asking you which of them is not a branched chain amino acid. So just make sure you read the questions and figure out what they're actually asking. The way to remember this: live on a branch. You have valine, leucine, and isoleucine are our branched chain amino acids. Now we stop and we think also valine, leucine, and isoleucine. All of those were also nonpolar. So you see there's a little bit of overlap. There's polar, nonpolar, aromatic, positively charged, negatively charged, and some of these things overlap. There's also branch chain. So these different categories that we put amino acids into that we want to make sure that we're aware of. Aromatic R groups. These are the ones are our ring structures. They contain an aromatic ring structure. The new little mnemonic to remember this one is your pal Tyrone will trip you in the ring. Pal phenylalanine, trip tyrosine. Oh, sorry, trip is tryptophan. Tyrone is tyrosine. I do these a lot. There's these when you get to boards, these are the ones they'll give you as well. You have the polar ones, again, can make something up like C tags. I don't know. Anything that's a little bit easier to help you remember. There goes PC tags. P for polar, C tags gives you a little bit there. Just anything you can do to make up, and then again, practice them multiple times in different days, forcing yourself to recall the information.
A question he likes to answer or ask is go down a little bit. Right there. About cysteine and methionine. He loves that question. He was quizzing me on it the other day in our one-on-one.
See, I do know what I'm talking about, guys. Watch my YouTube videos. Because if these are in here, it's because I put them in there with my YouTube videos. Yeah, he loves these questions.
He was throwing the third one down at me the other day too.
Yep.
Just a heads up, guys, tomorrow if you're in the blended, he's under the weather and he sounds a little hoarse.
It's all good. Okay. Here's another grouping that we want to do, just like we had branched chain amino acids. We want to know which ones are sulfur containing. The little mnemonic to remember this is to be an MC, you have to have sol. M is methionine, C is cysteine. And y'all can come back and watch this and write these down. Make sure that you use all of these and kind of this kind of stuff. I would write this down on paper and practice it on paper. The act of physically writing something, specifically for raw memorization, writing it down is much more effective at building the links in your brain. You don't have time to write everything down, but this specific thing will help a lot because these kind of questions will pop up a couple of times, not just in this exam, but also he asks some of these questions in Biochem 2 and in like other exams in Biochem 1.
Yep.
Positively charged R groups. I remember that. That's Hal. Hal is positive. If you've ever seen Malcolm in the Middle, I think of Hal. Negatively charged ions. Gah. Or ag. I don't know. Whatever. We have the acidic amino acids. This is, remember, acidity of ass and glutes. Those are also our negatively charged. So the two negatively charged ones are also our acidic. Okay. Have y'all talked about oxidation reduction at all?
Yes.
Yes.
We did.
Does oxidation reduction make sense?
Yes.
Kind of.
Kind of. Does anybody want me specifically to go over it right now?
It'd be helpful.
Okay.
Doesn't hurt.
Okay, so the way to remember this, oxidation is loss, reduction is gain, specifically of electrons. You can actually look at this a couple of different ways. So, oxidation is loss of electrons, or gaining of oxygen, or addition of hydrogen. Because hydrogen and oxygen both carry both. Oh, what was it? Oh, shoot. Let me double check. Sorry.
I like
For
your mnemonic for it.
loss. There it is. Oxidation is loss of electrons, or gaining of oxygen, or loss of hydrogen. There we go. Wanted to make sure that did not sound right because it was wrong.
It's gain of electron.
Okay, so oxidation is loss of electrons. So if any of these three things happen, oxidation is occurring. Okay. If any of these, you'll say that that is the thing that is being oxidized. Reduction is what receives. Let's see. Reduction is gain of electrons or gain of hydrogen or loss of oxygen. That's the simplest way to put it. You'll start to get in, you'll see a lot of words. So you'll see in oxidizing or an oxidation agent or a reducing agent. These are definition things that you'll see, and you'll get questions. Christian, correct me if I'm wrong, but he likes to ask questions about what the oxidized form is, what the reduced form is, which is the oxidizing agent, which is the reducing agent.
Yes, he does.
So, and this can get a little bit confusing. Oh, thank you. Okay. Hydration and snacks are very important, you guys. If you don't have a steady flow of hydration and snacks, you need them to survive.
I would add caffeine to that as well.
As long don't drink caffeine 10 to 12 hours before bed. It messes with your circadian rhythm, and y'all need sleep to survive in this program. Just a daily life tip. Do I always listen to
I
that
can
rule?
drink coffee all day.
I do not listen to that rule as much as I should, but it's a good rule to follow. Do as I say, not as I do. Okay. So reducing agent. The reducing agent, a substance that tends to bring about reduction. So it's going to cause reduction by being oxidized. So the reducing agent gets oxidized. So the reducing agent loses electrons, loses its hydrogen, or gains oxygen. So the oxidizing agent, what do we think happens to the oxidizing agent?
Gets reduced.
It gets reduced. And what does reduction mean?
Decrease.
Gain or
It's smaller.
okay, so it gains electrons, or it gains hydrogen, or it loses oxygen. The perfect example and the most common kind of structure, like things that he'll have you like asked about, we have something called NAD plus and NADH. Okay. Hopefully from previous courses, you've heard of both of these before. These are chemical structures. These are super, super important when it comes to energy production. At the very end of the trimester, you'll get into glycolysis and the Krebs cycle, and you'll really focus a lot on NADH, NAD plus, all of these guys and kind of what their purpose and their job is.
Yes, please know that, guys. That is your last 4 weeks of class.
Oh yeah. When we get into that, I love Krebs cycle. I think Krebs cycle is so much fun. I guess I'm not being tested on it, so I can think it's more fun, but
Krebs cycle was the one thing that my mentor was like, don't sleep on it. Like, you need to know it.
literally do not, because it will come back. It's all over boards as well. I don't know why, but it is. Okay. So NAD plus, right? NAD plus goes to NADH. So NADH. Let's look at this. NAD plus. It's going to receive hydrogens. So is NAD plus, is it a reducing agent or an oxidation agent?
Reduction.
The oxidation.
So this is where like the question, the way that the question is worded, it can get really confusing. So let's break it down. So NAD plus, what is going to happen to it? Is it going to get oxidized or is it going to get reduced? So it's going to gain hydrogen. So it will be reduced. So does that make it an oxidizing agent or a reducing agent?
Oxidizing.
An oxidizing or an oxidation agent. NAD plus, is it currently the structure, the way that it is, NAD plus, is it in its oxidized form or in its reduced form?
Oxidized.
Correct. In its oxidized form. Hashtag. Ooh. Hashtag oxidizing era. Okay. Does that all make sense? Each of these written out, so NAD plus will be reduced, which makes it the oxidizing agent, and it is currently, let's say, currently in its oxidized form. All of these are different ways that he can ask you this question. And that's where it can get really, really confusing, trying to figure out what the heck he is asking. So he'll ask you the question like, which of the following is the most reduced form of blank? And you have to look at it and be like, okay, which one, like what is he asking? Or it's like, which of the following is going to be the reducing agent in this chemical formula? And so you look at, okay, reducing agent. What does reducing agent mean? Reducing agent is the thing that gets oxidized. What is getting oxidized? Most commonly, look for the hydrogens, follow the hydrogens. That's a lot of what will change, especially like in the kind of biochemistry that we're looking at. That's what you really, really want to look at. And just kind of read the question carefully, and know this like the back of your hand, the form of stuff, because he can use this in other examples as well. For example, there's another one, FADH, which goes to FADH2. So then FADH is also an oxidizing agent, currently in its oxidized form and in oxidizing, and oxidizing agent. I wrote that. So will be reduced. There. That's what I was trying to write. Okay. Now NADH, the form that this is going to be, instead of the oxidized form, this is the reduced form. It's just going to be the opposite. It's the reduced form. It's the reducing agent, and it will get oxidized. If NADH gets oxidized, what does it become? What will it turn into?
NAD plus.
Plus.
Perfect. That's the kind of thought process that we want to have with these sort of questions. Those will pop up a good chunk of time. He likes that kind of question. So just gotta keep straight. What is the question asking? Is it asking what is getting oxidized? What is getting reduced? What is the oxidizing or the reducing agent? Or overall is it an oxidation reaction or not? Those kind of things. Like it's like all those different pieces. If you understand the definition of them, of like what is actually occurring, that's going to help you answer those questions a lot easier. Okay. This will come back later on. Don't need to worry a ton about this. Just like know this disulfide binds and insulin stabilizes functional structure. This will come back. Just you want to know disulfide bonds, what forms the disulfide bonds, and this whole section is a little bit kind of out, but it's between mostly cysteine. Cysteine forms the double bonds. Cysteine, once it forms the double bond, it's then called cysteine. Cysteine, it's the same thing, just one is bound to another, the other is still separate. Don't let that trip you up too much.
He makes fun of me with my name for remembering that one. Christine, cysteine.
There we go. Okay, we have a zwitterion. Zwitterion. Just know the definition of this. The definition is that at neutral pH, it's a zwitterion, which means it can act as either an acid or a base. So a lot of our amino acids at neutral pH are zwitterions, just that they can act as either an acid or a base, depending on what they need to do. This is just more definition stuff. Isoelectric pH is
He
just
likes those questions.
when the net charge is 0. Yeah, he'll probably ask you a question, almost like word for word definition of this. If he asks you a question about that, it's gonna be word for word definition. Titration, a lot of this is like math kind of stuff. He really didn't ask questions about titration when I was there.
I didn't see many last try.
Yeah. Like if he does, it's like one question. And to be straight up, titration is its whole, like is a whole beast that don't go down that rabbit hole. Like even if you get like 2, 3, 4 questions out of 50 on titration, just do your best guess and move on. Like it's not worth it to spend like the 3-4 hours that it takes to fully understand titration. Just to get those couple of points. Like all of this sort of stuff. Yeah. Okay. This next part, this is really important. the amino acids are polymerized, polymerization, poly meaning multiple, merization, like combining, so combining of multiple things through a reaction called condensation in order to form peptide bonds. Peptide bonds are just a fancy way of saying covalent bonds formed between amino acids. Between amino acids. Okay, so a peptide bond is a covalent bond. It's kind of like this square rectangle situation. Not all covalent bonds are peptide bonds, but all peptide bonds are covalent bonds. Okay. A condensation, we have two reaction types. We have condensation, and the opposite is hydration. They both involve water. A condensation reaction, the two molecules combine to form a single molecule. So here we go. These two amino acids are combining. And a small molecule, in this case water, will be removed during a condensation reaction. So what's really cool about reactions and the naming of them is if you know one of them, you should know what happens with the other one as well. So condensation, two amino acids join together and water comes off. If hydration is the opposite, what do we think happens in a hydration reaction?
Water is
Water
added.
is added.
Water is added, and what happens to those two things that were bound together?
They
They
dissociate.
break apart.
Exactly, they dissociate, aka break apart. Sweet. Approach reactions that way. If you understand what one does, reverse it, and that's what the other reaction should do. That way you only have to really learn half of them. Interactions in proteins. We're going to come back to this when we talk about the structure, because this will be a very important point later on. We'll talk about hydrogen bonds. Hydrogen bonds play a big role in full protein structure. Okay. So we get peptide bonds forming, and as they form, it builds a nice little chain, and we call that a polypeptide chain. Okay. We have an amino terminal end. Sometimes they'll just call that the A end. And then a carboxyl terminal end, or the C end. If we look at these, it's called the amino terminal end because look at this. It has an amino group at the end of it. And this is the carboxyl terminal end because it has a carboxyl group right there. Polypeptide chains are built. We say that they're built amino and 2 carboxyl end. Come on, there it goes. So that means that we build it. This is where we start over here. This is the first one that we started with. And we build the chain this way, adding on to the carboxyl end. That's how we build that's how we build polypeptide chains. This is how he'll word those kind of questions. He'll say like either the amino terminal or the A terminal or the C terminal. He'll say which of the following, he'll say like, it'll probably like a true or false and something along the lines of like within building a polypeptide chain, the chain is built C to A terminal or C terminal to A terminal. And that's false because it's built A terminal to C terminal. Something sort of along those lines is the way that he'll put it. Modifications, not super important right now. We'll get back into this later on. I guess kind of. Modifications. So understand modifications of amino acids of the R groups. Modifications mean adding or taking something away from the R group to change its properties, to change what it's doing, to help it like do whatever job it needs to do. There's a whole bunch of them here. These ones that I have mentioned, these guys that I already have definitions for, these will be the ones that you'll kind of want to remember. I don't remember. I don't feel like they come up a ton in the first exam, but they come up later on down the road, if I remember correctly.
Carboxylations, I know on the first one.
Carboxylation is?
Yeah. At least it's mentioned once.
Okay. So like as long as like if you know the definition, and hopefully like some of these should be a little bit obvious. Phosphorylation, adding a phosphate group. Acetylation, adding an acetyl group. Methylation, adding a methyl group. Carboxylation, adding a carbon dioxide, a carboxyl group. Hydroxylation, adding a carbon hydrogen. So yeah. Like as long as you know definitions, you should be okay with that. That's not too, you don't go too in depth in all of this. This stuff, like the moieties, I don't remember him talking about at all. Like I
Nope.
legitimately don't remember this at all. So
Neither do I.
personally, I would not even like just go away spooky stuff. It's like, no, thank you. Like I would not worry about this at all right now. Again, like if it's like a whole bunch of stuff that he never talked about, he might throw in one question somewhere about all of this. But again, is it really worth the multiple hours to understand this whole thing just for that one question? Probably not. More spooky stuff. Go away, go away, go away. Here's like the modification. Just kind of just shows you those things, and that's all of chapter 2. Chapter 3. How's everybody doing up to this point?
Good.
We've covered a lot of information, so
Okay.
a couple things a little bit clearer going back through them like this.
Mm-hmm.
Yes. Wish I would have watched these from the get-go last trimester. I wouldn't be here.
Sweet. Overview of protein structure and function. Proteins, they have what's called a covalent backbone. Remember we talked about peptide bonds. Who can tell me what a peptide bond is? What two things are bound together?
Amino acids.
Correct. Great job, Lauren. So amino acids come together to form peptide bonds. Peptide bonds are a type of covalent bond, and we get this big, long, beautiful chain. Okay? You guys can come back, go read through this. Just like this is just talking about like all of the fun stuff that proteins do. Proteins do a whole bunch of stuff. We have bonding again. Classification of proteins. This is more just kind of raw memorization. Sorry, we're gonna get through this and then we'll get to like where I was going with the structure stuff. Things to remember: fibrous. Think about like if you put fibers. Think about like grass. If you put grass into a glass of water, it just sits there. Like it's not gonna, you can mix it as much as you want. The grass isn't just gonna dissolve into the liquid. So that's when it talks about fibrous. It's insoluble, and its job is to support structures. Lily, hey, stop that, please. Come here. Okay. Sorry, my cat was destroying something. So fibrous, that supports the structure. It's insoluble, it doesn't break down in water. Think of that like the grass. And then globular. Globular is the stuff that dissolves in water, mixes into water. Stuff like our globular globins, myoglobin, hemoglobin, that sort of stuff is water soluble. I feel like if I remember correctly, that's as deep as he goes into fibrous versus globular. This actually comes back up, this stuff, these protein structures, if it hasn't already, in BCT. There's a good chunk of overlap when it comes to protein structure with BCT and biochemistry. Let me see if
And
I
there's
can
an
quickly.
overlap between micro and biochemistry.
Connective tissue, macromolecule cell structure. Might be here, or it is here, one of the two. Let me see. It might be like your second exam in BCT that this comes back through.
This
But
stuff's
it
on our first exam.
is on the first
on one of
exam.
the PowerPoints. Yeah.
Okay.
Yeah.
Yeah. So this stuff comes back, and then you'll see it again. Or this might be the second time you're seeing it. So there's a little bit of overlap there. This again is just going over some stuff, proteins. There's that same condensation to form peptide bond again. Amino to carboxyl terminal end. He might mention this trans versus cis configuration. Again, this is one of those things that 99% of the time answer is going to be trans configuration. So he'll have like two peptides where it has like the beginning, like it says cis or trans, whatever afterwards. Most likely pick trans because it's more common. So like if you don't know, it's kind of like whatever, pick the answer that's more likely.
Another trick for his exams, do not overthink questions.
It's okay. Yeah. Oh, yeah. Now getting back to the peptide chain, this kind of stuff. This is what, again, you should see this if you haven't already seen it. Have you already seen this in cells and tissues? The protein structure stuff?
Yes.
Yeah.
Okay.
Yeah.
So this is kind of a repeat. I just want to go over, hit the highlights of like what you really, really need to know. Know the definition. A primary structure is the amino acid sequence of the polypeptide chain. So it's just the chain, long string of amino acids all together. That is the primary structure. The type of bonds that you will see there primarily are covalent peptide bonds. You need to know what kind of bonds are responsible for that for each of these structures. Ow, hey, don't bite me. So covalent peptide bonds, that's the big one to remember. So here we have our peptide chain. Also the disulfide linkage, but mostly you're going to be asked, it's going to be the peptide bonds. The peptide bonds is most of it. Secondary structure. So our chain starts to fold and starts to interact with the other parts of itself. And it will fold into one of two 3D structures. It's going to fold either into an alpha helix or a beta pleated sheet. And this is due to hydrogen bonds. Remember that hydrogen bonds are responsible for alpha helix and beta pleated sheets. Okay. And these are our secondary structures. Okay. I was checking to see if it does have it here. Mostly in the body, pretty much everything is a right-handed helix. He's asked like one question about that in the past. And it was super straightforward. Just it's a right-handed, because the right-handed helix is more stable. So that might be a question thrown in there, but remember, right is right. Right-handed is the correct answer. Beta pleated sheets. Here we have a couple of different forms of this. Remember, we talked about how our polypeptide chain had the amino end and the carboxyl end. So however this forms, you can have a couple different types. You can have the anti-parallel. So this would mean you have an N terminal and a C terminal like this. C and it doesn't call it A terminal, it calls it N terminal. Way back up here, I was saying A terminal, but correction, it says it's N terminal, N and C. That's the way he says it. So you have antiparallel, they run. Wait, so the way that he'll ask his question, like the answer will be in the form of N terminal to C terminal on top of C terminal to N terminal. That would be the answer to a question like in an anti-parallel beta sheet. Which direction does the polypeptide chain run? N terminal, C terminal on top of C terminal to N terminal, something like that. The parallel beta sheets are all lined up, N terminal to C terminal, N terminal, C terminal, N terminal to C N terminal. And what connects them, just like in the alpha helix, it's hydrogen bonds. If you remember anything, you need to know what each of the structures are. Primary structure is the amino acid chain and what kind of bonds they have. So primary amino acid chain, peptide bonds, which are covalent. Secondary structure, alpha helices, beta pleated sheets, hydrogen bonds. Continuing through. This will be another test question. The turns in the beta pleated sheets, like what makes it kind of turn and continue to form, is thanks to glycine and proline being next to each other. I promise you this is a test question. I promise
it
you.
is. Even on quizzes.
Is there enough stars there? Just you guys that are here right now, mark it down. I guarantee you. At this point, I've given you at least 10 to 15 test questions, word for word, what they're going to be. So there you go. If you'd already know the answer to 10 or 10, even like that's what, 1/5 of the quiz or 1/5 of the exam. If you guys know 1/5 of it, you're already on the way of having a much easier exam. Okay, this is because glycine is small and flexible. This is explaining why they forms the beta turns. Proline is an imino-nitrogen, meaning that it doesn't contain hydrogen. So it's the only one that forms the cis configuration rather than the trans configuration. So that's potentially another test question of which of the following forms cis configuration. Proline. That'll be the only one that does that. So you see, whenever you have a glycine proline together, or even if they're close, it's possible to have a beta turn in the sheets. Okay, that's secondary structure. What type of bond holds together secondary structure?
Hydrogen.
Hydrogen. What kind of bond holds a primary structure?
Covalent.
Correct. Covalent, aka a peptide bond. You can see either on the test. Tertiary structure. So we have this super long chain of amino acids. So let's say our chain of amino acids is like 600-700 amino acids long for a protein. So at the very, very beginning, it can turn into an alpha helix. After that, a little bit further down, it'll form a beta pleated sheet. Let's say it forms an anti-parallel beta pleated sheet. A little bit later, it forms another beta sheet. A little bit later, another alpha helix. A little bit later, another alpha helix. Then again, beta pleated sheet, and so on. So different parts of our full chain will form those secondary structures. So you can have multiple secondary structures on one chain. Okay, does that make sense to everybody?
Yes.
Okay. Tertiary structure is when all of those secondary structures fold up together, interact with each other to form a bigger structure. Okay, so each of the secondary structures that have formed throughout the whole chain interact with each other again through hydrogen bonding, and they fold up and they form a tertiary structure. Now, for some proteins, there we go. This is their final structure. They are functional just like this. Okay. So they fold all up and they can start going and doing their function. You have the one structure that he might ask you about. They'll form motifs, which are common patterns, like a beta alpha beta loop. So you have two beta pleated sheets and alpha helix loop. It's just like a common structure. You'll see some of these common structures more in cells and tissues, and you'll get questioned on those in cells and tissues more than you will here. Here, you just need to know structure and bonds. Okay. Like I said, so some proteins, tertiary structure, they hit tertiary structure. That's it. They're done. They're good to go. They're functional. They go off and they do their job. For others, you need multiple tertiary structures. So this is the combination of multiple tertiary structures to form a functional protein. One of the most common examples of this that you'll see that they'll talk about is hemoglobin. Hemoglobin is the protein in your blood that transports oxygen. Because it's globin, it's a globular protein. Are globular proteins soluble or insoluble in liquid or in water?
Soluble.
Soluble.
What was the other kind of protein that we talked about that was insoluble?
Fibers.
Fibers.
Perfect. Good job. So then all of these guys, so these multiple tertiary structures will all come together and kind of sandwich and form and be all put together in order to form a quaternary, I can't even pronounce that, quaternary structure, whatever you want to say. It's 4. It's the 4th stage. The subunits, so all these things are joined by non-covalent interactions. That has another name. Yeah, they call them, you might also see them called van der Waals forces. I don't think you really, I think that was like on one test question somewhere, but you should be good just understanding non-covalent interactions. So just repeating, primary structure, it's the chain, peptide bonds, secondary structure, alpha helix, beta pleated sheets, hydrogen bonds, tertiary structure through hydrogen bonding again, and then quaternary structure through, this is multiple tertiaries put together to form a functional protein, and they join through non-covalent interactions, also known as, one of the things that is known as van der Waals forces. And there's just the all the way through. Only other thing that we would talk about that he'll ask about questions about really is protein denaturation and folding. So basically this is talking about you can destroy a protein by messing with its structure and with its bonding. The way that you do that is heat, drastically changing pH levels, or other reagents, which such as detergent, urea, alcohols, very strong bases, or some other non-enzymatic modifications. So he'll ask a question or two kind of about this denaturing of proteins, like along the lines of which of the following would completely denature a protein. And then you have to say like the answers would be like super high heat, the use of a detergent, the use of an alcohol, like drastic change in pH, or he'd probably ask the question of which of the following will not denature a protein. So then he'd give you 4 choices, and several of these would be on here, and just one of them is wrong. Is that like an actual question that you remember, Kristen?
Yep.
Look at there.
I may not
So,
do
yeah.
well on exams, but I do have a pretty good photographic memory.
Yeah. So again, some kind of test question along those lines. Here we go. Other thing as well, I remember him asking a question about this as well, where he's like, if the protein is not fully denatured and completely ripped apart, so let's say the pH goes outside of a range, let's say the pH goes all the way up to 8. And then quickly after the fact, it's brought back down to 7.3, 7.4. If it's not, the protein isn't completely destroyed, it will refold back into its functional structure. Because remember, the way that it forms that structure is through the hydrogen bonding of itself. So if it's put into a situation where it can refold and reform those bonds, it'll do that naturally by itself, and it can renature and go back to being a functional protein. This is just talking about hemoglobin, myoglobin. I'd come through and read those. This stuff, he don't really talk a lot about this stuff from what I remember. A little bit into this.
Uh-huh.
But I'm gonna be completely honest. I think I'm hitting my wall of brain power. I don't know how y'all are feeling, but I think for today we'll stop there. We hit the most important stuff. We can hit this stuff a little bit more later on. I would highly recommend the Bohr effect. This stuff here, this comes back a lot in Phys 1 and some in Phys 2, and again in Tri 4 with systems pathology. It's like, so you got, I promise you guys this stuff, there's a reason why you have to learn this stuff, I promise. It's not just because the teachers hate you. I promise.
And they don't hate you.
They don't. They really don't. We'll get back into this, and I would spend a little bit of time on this, specifically this kind of curve, the shifting, the right and the left shift. Khan Academy, Ninja Nerd should have some really good material on this. I think that I should have spent time in one of my YouTube videos going over all of this. So go back and watch those. So, and you'll see kind of the shifts, understanding it. Because you will have a handful of questions about shifting. I don't remember if specifically if it's in biochem in this class or if it's in a future course, but you will have questions about this. So yeah, and I'll just end it right here. He'll ask about this. Fetal hemoglobin. There's always a question about this, about how fetal hemoglobin has higher affinity for oxygen than adult hemoglobin. That's always a question. So there you go. That's like 15-ish questions on your test. Getting you there. Okay. Guys, I'm gonna go ahead and end here. Like I said, I'll download this video, post it to YouTube. So you can come back and you can rewatch it if you need to. We'll make a plan. Also on the YouTube channel, there is the full exam 1 review. So going through the entire study guide and going through all of it and recreating the study guide. So as we start to get a little closer to the exam, make sure y'all check that out and make sure that you're staying on top of reviewing for stuff, kind of the things that we've talked about. Overall, the understanding the naming of the functional groups, the different amino acids, the different groupings of amino acids, polar versus non-polar, positive, negative, acidic, basic, sulfur containing, branch chain, the aromatic ring containing ones, et cetera, all this kind of stuff. Because all of those, it takes some time. And like I said, it's just raw memorization. But if you can get that now and not have to cram that before the test, it'll be easy points on the first exam. I always say my rule of thumb for going about classes in this program, really put forth absolute maximum effort for the first wave of exams. First exam, just put your head down, really spend as much time as you can to understand the material and do well on the first exam. If you do great on the first exam, you don't have to try as hard come finals time. Okay? Don't start yourself out on a mountain, not digging yourself into a hole. Before we log off, any last minute questions, concerns, comments, ideas, jokes?
Appreciate it, man. It was very helpful tonight.
Good. Glad I could help you guys.
Definitely appreciate it.
All right, everybody, have a great night. Get some sleep, and good luck with the rest of your week.
Thank you, Drake.
Thank you, Drake.
Bye.
Bye.
Thank you.
Thank you.